Okay guys, moving right along, we're going to talk about graphing in vertex form. So first, just a quick review. Vertex form is written in the form of f of x equals a times, open parentheses, x minus h all squared plus k. So when we're looking at this form, the first thing we want to identify is a, h, and k. The easiest of the two is the a value and the k value because I'm looking at exactly what those values are. But you have to remember that you're looking at the opposite of h, and so when you identify who h is, you got to remember to flip that value around. So a in this function here, that we have f of x is equal to 1/2 times x minus 3 all squared minus 4. So our a value is 1/2. Our h value is positive 3 because I'm looking at the opposite, and k is negative 4. Our vertex, when we're in vertex form, is at hk. So it's really easy when you're in vertex form to identify the vertex. And so we're going to plot that right here on our chart, 3, negative 4. Now, I chose this particular function because, as in all quadratics, when you bump into some fractions and you're looking to create a set of values that you can use to plot your 5 points, it's handy to choose values that work with the fractions nicely. So what I'm going to do is, as I build to the left and the right symmetrically in either direction, I'm going to go equidistant from that value of 3, but I'm going to choose to hop in values of 2 units, because as I go 2 units, each of those values will play nicely with the 1/2. If there's a 1/3, I might choose to go with 3 units. And again, second table on the graphing calculator also will help you to build that table. And so I'm going to go 2 units this way to 5 and then to 7. And in that direction, I'm going to go 3 minus 2 is 1, minus 2 is another negative 1. The nice thing about this one is I'm going to use these 2 values to find the y values and then reflect them across to find the other 2. So as I start to build my chart, I'm going to substitute in my 2 points on the left because they're the easiest to substitute in. And I'm going to take my f of negative 1, substitute that in. F of negative 1 is equal to 1/2 times negative 1, minus 3, all squared, minus 4. So that's going to give me 1/2 negative 4 all squared minus 4. That's equal to 1/2 of positive 16, because negative 4 squared is positive 16. Half of positive 16 is 8, and 8 minus 4 is 4. So I'm going to come over here and write 4, and also the reflection of that point across that axis of symmetry is 4. I do the same thing with positive 1. I have f of positive 1 is equal to 1/2 times 1 minus 3, all squared, minus 4. So that's going to be 1/2 of, and again, 1 minus 3 is a negative 2, and negative 2 squared is positive 4, so it's 1/2 of 4 minus 4. That's 2 minus 4. I'm going to get a value of negative 2. I'm going to put that right here and right here. And so what I'm looking at now is it looks like as I go out from the vertex, my y values are getting greater, and as I failed to mention in the first video, or just a reminder, that a value in all forms is dictating a couple of items. One of the items that is dictating is which way the parabola is opening. If a is positive, the parabola opens up. If a is negative, the parabola opens down. In this case, a is positive, so we have 3, negative 4, 1, 2, 3, 1, 2, 3, 4. There's our lowest point of the parabola because it's opening up. 1, negative 2, so I come over 1, go down 2, and I come over to 5, 3, 5, and down 2, and then I come over 2 more to 7, and 2 more to negative 1, and I'm going to go up to a value of 4, and 4. And what I've noticed differently about this sketch, and bear in mind that it is a sketch, it's not perfect graph paper, is that this one is a little bit wider, and that's our final input on the a value, is that if that value, if the absolute value of a is less than 0, or if it's a fractional value, a proper fractional value, like 1/2, 1/3, 1/7, the parabola is going to open wider, and if a is greater than 1, the absolute value of it, the parabola will open narrower. So say if this were 8, that parabola would open super narrow as compared to the parent function. Now for our grand finale, graphing in intercept form. Hopefully, after factoring, intercept form starts to make a little bit more sense. when we're factoring, we're actually looking for or finding our intercepts. So looking back on this now, I hope that this was all coming together for you. When we're in intercept form, we have f of x is equal to a, again, a dictating whether or not this thing is opening up or down, wider or narrower than our parent function. A times open parentheses x minus p times x minus q, where p and q are our x-intercepts. Those are the values of x that drive y to 0. So our two intercepts will be at p comma 0 and q comma 0. And our function here, what I've chosen, is one that's a little bit tricky. One, because there is no, sort of explicit a value. It's implied that a at this moment is a negative 1. So we have the negative sign out there, but no number, which means that that value is a 1. And we have x plus 1 here. So looking at the fact that we are looking at the opposites of p and the opposite of q, p is going to be negative 1 and q is going to be positive 5, thus putting our intercepts at negative 1 and 5, 0. So if we were looking at a graph really quickly, negative 1, 0 is an intercept, and 1, 2, 3, 4, 5, comma 0 is an intercept. I know that this is opening down, so I know that my parabola does something like this, and that my axis of symmetry is right around there. Now, it's at x equals the x value of the vertex. So I'm looking to decide, well, where is my vertex? It's halfway between these 2 points. So if I take the negative 1 x coordinate of this point, and I take the positive 5 of the other coordinate, and I add them together, and I average them out, I'm going to get 4 divided by 2, 2. 2 is the x coordinate of my vertex. And by method of substitution for that value, I will come to realize that the y value is 9. So this point up here, this maximum, is at 2 comma 9. And my axis of symmetry is at x equals 2. So knowing that 2, 9 is my vertex, I want to go out in either direction, and I can go by 1 or 2. The problem is I would like to use these points since I already have them. So negative 1, 0 I'm going to put out here, and then 5, 0 I know goes here. Now it's 3 units this way and 3 units that way, so anything in between will work. It's not a fractional a value, so essentially the world is my oyster. I like 0 because it's such an easy number to go in, to substitute back into. So 0 is 2 units from 2, so I'll go 2 units from 2 in the other way, and I'll choose 4. And 5 is the value after I substitute 0 in for x in here. I get 0 plus 1 is 1, and 0 minus 5 is negative 5. Negative 5 times 1 is negative 5, times negative 1 is positive 5. I reflect that back over here, and then what I would do is I would, plot those points there, and I would have my final graph. And that's that.